Okay, so I'm going to show you a quick video on dimensional analysis. Since I'm not going to be here, hopefully this will help you guys. I'm going to go really fast. If you need to pause the video, go ahead. All right, we're going to talk about what is dimensional analysis, what are conversion factors, and go through some problems. First thing is, and we kind of talked about this before, but dimensional analysis is just a tool that you use to convert from one unit to another within a system or between systems. To be able to do that, you need to know the conversion factors. What can get you from inches to centimeters, or from feet to kilometers, things like that. Okay, it's just a numerical factor that you use to get from a quantity in one system to a different system just to be able to convert the units. Sometimes dimensional analysis is called the factor label method, meaning if you set up all of your units and you label them all properly, the ones that you don't need will be factored or canceled out. Like centimeters cubed times gram per centimeters cubed, the centimeters cubed end up canceling out and you're left with grams. All right, what are the steps you should go through in each one of these problems? First, identify where you're starting and where you're ending. Then line up all the conversion factors labeled properly with all of your units so you can see which ones cancel out and that they cancel properly. Then multiply all the numbers on the top, divide by each number on the bottom. And then when you get to your final answer, check it for units, sig figs, and whether or not it seems to make sense. Okay, what's a conversion factor? It is a fraction in which the numerator and denominator are actually equivalent quantities just expressed in different units. For example, 1 inch equals 2.54 centimeters. You could write it as this, 1 inch over 2.54 centimeters, or 2.54 centimeters over an inch, depending on which way you're trying to convert. This is an example problem. How many minutes are in an hour? You would start with 2.54 hours. Some people like to write it over 1. Then you multiply it by this conversion factor that you're all familiar with. There are 60 minutes in an hour. This is your conversion factor. These units will cancel out and you're left with 150 minutes. Okay, so let's just go through a few quickly. What would be the conversion factors here? If you'd like to try it on your own, pause it. I'm just going to go through them. Liters to milliliters, or milliliters to liters. These are in the metric system and you should know, and if you don't, I'll go through that in a second. There are 1,000 milliliters in a liter, or you can write it the other way, 1,000 milliliters over 1 liter, depending on which way you're converting. Hours to minutes, we just went through that one, 1 hour, 60 minutes. Meters and kilometers, there are 1,000 meters in a kilometer, or 1 kilometer over 1,000 meters, depending again which way you're converting. So you're like, I'm not sure about those metric ones. All right, you need to know the metric system. I'm going to show you a couple of slides that go through all the prefixes you need to be comfortable with. Kind of have to memorize them. And then I use dimensional analysis to convert. Some people like to just move the decimal, which sometimes is fine unless you're moving it like 24 places. Then you probably want to actually set it up in dimensional analysis. Find the conversion factors you need and then insert them correctly to get from meters to kilometers, or from micrometers to nanometers. Okay, these are these are the system, the prefixes in the metric system you've probably learned in the past. Kilo, hecto, deca, base unit, meters, liters, grams, seconds, bytes, deci, centi, and milli. King Henry died by drinking chocolate milk. You've probably learned those before, and to move each one of these places, you just move the decimal one place, either to the left or to the right. It's kind of probably how you learned it. There are more than these. There are a lot more. We're only going to talk about 6 more. Tera, giga, and mega, T, G, and M. And micro, nano, pico. Micro is the weird one with the weird symbol there. Something else to notice, when you're going from kilo to mega, you're not moving the decimal one place. It's 3, 3, 3. Same thing here, from milli to micro, 3, to nano, 3 more, and pico, 3 more. Instead of moving it just 1, it's 3. Okay, there's kind of a way to remember them too. The great man, Tera, giga, mega. King Henry died by drinking chocolate milk. Monday night partying, micro, nano, pico. Just another way to help you try to memorize those. Some people like to write it out in a string of them like this. Tera, giga, mega, kilo, hecto, deca, base units, deci, centi, milli, micro, nano, pico. I'm going to put these in a box here, and these in a box here. Number 1, because they're new. Number 2, because you need to remember when you're making this jump from here to here, you need to move the decimal 3 places, not just 1. So let's go through a few conversion factors. Centimeters to meters, that's base unit and centi. So you would move the decimal 2 places. There are 100 centimeters in a meter. To go from meters to micrometers or micrometers, base unit to micro, 1, 2, 3, 4, 5, 6. There are 10 to the 6th micrometers in a meter. Nanoseconds to seconds. Seconds would be your base unit, and we're trying to go to nano. 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 10 to the 9th nanoseconds in a second. Kilograms to grams, one you're probably more familiar with. Here's kilo and here's grams, which is your base unit. 1, 2, 3, there are 1,000 grams in a kilogram, or 10 to the third. Okay, let's do these three conversions. 20 centimeters is how many meters? You can do it by dimensional analysis or just move your decimal. If you know it's 100, you're dividing this by 100. 0.2. 0.032 liters is how many milliliters? There are 1,000 milliliters in a liter, so you're multiplying by 1,000, so it'd be 32. 45 micrometers or micrometers. There are a lot more micrometers in a meter, so now we're looking at a small number because now we're going this way. 1, 2, 3, so we go from here, 3, 4, 5, 6. There are 10 to the 6th micrometers in a meter, so you're dividing by 10 to the 6th. And so it's 45 times 10 to the negative 6, but that's not proper scientific notation. It would be 4.5 times 10 to the negative 5th. If you find yourself writing more than 3 zeros, make sure you put it in scientific notation. Okay, terabytes to bytes. So tera is way over here, and now we're trying to go to bytes, which is a base unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 10 to the 12th bytes in 1 terabyte. So you can just write it like that, and you can even put it like that in your answer. 805 times 10 to the 12 terabytes. This is the way I'll set up my dimensional analysis problems. You can set them up either as step times step times step, or in one long string. This is improper scientific notation. If you type in your calculator, it'll fix it, or you can fix it. This is the coefficient, this is the exponent. If you make your coefficient smaller, your exponent gets bigger. If I make this smaller by 2 powers of 10, make this larger by 2 powers of 10. 8.05 times 10 to the 14th. That's the actual correct answer there. Here's 2 more. If you want to try them on your own, pause it. I'm going to go through them pretty quickly. A lot of times when you're going from a non-base unit to another non-base unit, people will go through the base unit to do the conversion. Meaning, I know there are 10 to the 6th micrograms in a gram, and then 10 to the 3rd grams in a kilogram, which means a total of 10 to the 9th, but you can set it up in 2 steps. 10 to the 6th micrograms in a gram, and then 10 to the 3rd grams in a kilogram. So 400 times 10 to the negative 9th, again improper scientific notation, but if you type that in your calculator, it will just fix it for you. 4.00, why do I include those zeros? This decimal here tells me they're significant, so I have to include it when I make my conversion. 3 significant figures, 3 significant figures. Megameters to nanometers. So now we're going from mega all the way over here to nano. Some people like to go to the base unit and then over, or you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 10 to the 15th nanometers in a megameter, which would mean this is 5.7 times 10 to the 15th. But again, that's improper scientific notation. 57 times 10 to the 15th. If you correct it, 5.7 times 10 to the 16th nanometers. Okay, that's it for metric conversions. We're going to move on to dimensional analysis practice. All these problems are on the back of the handout that you got that say follow along with the notes. So here's an easy one. You have $7.25 in your pocket in quarters. How many quarters do you have? You know, like I could figure that out. But if I said I want to see in dimensional analysis, this is what I'm looking for. You start off with the amount you're given, $7.25. You can put it over 1 as a placeholder again. And some people write it like this, times fraction. And you write that as a whole string of fractions. I'm fine with that. As long as your units are labeled, you can see that they cancel. 7.25 times 4 gives you 29. Do we need to evaluate this for sig figs? No, because it's a counting number and counting numbers are exact. Okay, next problem. How many seconds are in 1.4 days? So if you have 1.4 days and you're trying to convert to seconds, you're going to have to do more than one step. You probably go from days to hours to minutes to seconds. And so kind of set up that plan and figure out all the conversion factors that you need. So I'm going to start with my 1.4 days, put that over 1. This is the way I'll show the problems. Now we're going to go from days to hours. There are 24 hours in a day. Hours has to go on top, days have to go on the bottom, so they cancel. And now we're in hours, now we're going to go to minutes. There are 60 minutes in an hour. 60 minutes has to go on top, 1 hour on the bottom, so your hours cancel out. And then you're going to go from minutes to seconds. There are 60 seconds in a minute. And now you take 1.4 times 24 times 60 times 60, and you get this answer, 120,960. You can't say that with any certainty because this only has the precision of 2 significant figures, which means your answer can only have 2 significant figures. This does not limit you, it's exact, exact, exact. So the only thing that limits you is this 1.4 days that's been measured. So the two significant figures, it'd be 120,000 seconds. But now we just wrote 4 zeros. And if it's more than 3 zeros, what do you have to do? Put in scientific notation. 1.2 times 10 to the 5th seconds. Okay, next problem. How many milliliters are in 1 quart of milk? Quarts is a measurement of volume. So is milliliters, but they're in different systems. Metric system, English system. If you look at the back of the new periodic table you've just been given, there are a list of English to metric conversions. And this is something you would not have to memorize, I would give to you. So how can we get from quarts to milliliters? Well, you're like, well, I don't have a conversion from quarts to milliliters, but there's one on here from quarts to liters. Then we can get from liters to milliliters. So that needs to be our plan. Quarts to liters to milliliters. So I'm starting with my 1.00 quarts. And this, again, means to multiply this step times this step times this step. If you look at the sheet, it tells you there are 1.0567 quarts in a liter. Quarts on the top, quarts on the bottom, so they'll cancel. Now we're in liters, and we want to get to milliliters. Easy conversion. 1,000 milliliters is equivalent to a liter. And now our liters cancel out. And now we're in milliliters, which is the unit we wanted to be in. We started with 3 significant figures. The conversion factor we used has 5, so it doesn't limit us. This is exact, so our answer can only have 3, 946 milliliters. All right, next problem. You have 1.5 pounds of gold. Find its volume in cubic centimeters if the density of gold is 19.3 grams per cubic centimeter. This one's a little challenging because you have 2 numbers, and one of them looks kind of weird because of these units. Density in itself is a conversion factor. This is saying if I have 19.3 grams of gold, it will weigh 19.3 grams of gold, weighs 19.3 grams. It will take up 1 cubic centimeter. Or if I have 1 cubic centimeter of gold, it will weigh 19.3 grams. These two are equivalent to each other, and this is only true for gold. If we were using some other substance, it would have its own density. For example, water, 1 cubic centimeter of water weighs 1 gram. Gold is much more dense. So we can use this to convert from a unit of volume to a unit of mass, or from a unit of mass to a unit of volume, depending on what we're trying to do. We're starting with pounds, which is mass, and we're trying to get to volume. So how do we do that? We need the density along the way. Okay, so we're going to start with our 1.5 pounds because this is not our starting point. It is a conversion factor. Do not write this as one part together. It splits it up. This is telling you right here we got a fraction. 19.3 grams is equivalent to 1 cubic centimeter. We're going to use one of these two. It just depends which one we need to cancel out our units properly. We're going to start with pounds. Pounds is a unit of mass. What other unit of mass do we have? Grams. How do we get from pounds to grams? Well, they're in different systems. So you look at your sheet and you're like, well, I don't know how many pounds are in a gram, but I know how many pounds are in a kilogram. And then I can get from kilograms to grams. So your sheet tells you there are 2.205 pounds in a kilogram. So now we're in kilograms, and we can easily get from kilograms to grams because you know there are 1,000 grams in a kilogram. And now we're in grams, but we want to get to cubic centimeters. That's when we can use this. You don't want to use it this way because then it'd be grams here times grams here over cubic centimeters, which is grams squared per cubic centimeters, which is not what we want. We want cubic centimeters, so we're going to use it written this way, which flips this over and puts our grams on the bottom and our cubic centimeters on the top, but we're allowed to write it that way because remember, these two are equivalent. So now our grams cancel out, we're in cubic centimeters, and now we look back to see how many significant figures we have. 2 here, 3 here, 4 here, exact, and 3. So that's 2 significant figures. That's all we can have in our answer. So you should get 35 cubic centimeters. Okay, back to an easy one. You should probably pause this, see if you can do the next 2 on your own. I'm going to go through them quickly now. Okay, your hairdresser wants to cut off 8 centimeters of your hair. How many inches will that be? This is a simple one because it only requires 1 step. We're going from centimeters to inches, and your sheet tells you how many centimeters are in an inch. So we start with our 8 centimeters, and you can see that in 1 inch, there are 2.54 centimeters. Why do the centimeters go on the bottom? So they can cancel out. And then you multiply 8 times 1, which you don't have to do, divide by 2.54, and this is 2 significant figures. So our answer can have 2. You should get 3.1 inches. Another one that's easy you should do on your own, and then check back, is this one. So hopefully you've already tried it. Crossfield football needs 550 centimeters for our first down. How many yards is this? We're going to go from centimeters to yards. Both measurements of length, just in different systems. So there's a few different ways. I'm going to show you the way that I would go from centimeters to yards. I would go from centimeters to inches to feet to yards. So that's my plan. I'm going from centimeters to inches, which we just